What are humans? Sort of a loaded question. I would say there's three things about humans. We're a skeleton, we're tissues and water, and what's the third thing that we are? Yeah, microbes. And it's almost like people have woken up to realize, wait a minute, if you include that, then it changes the whole paradigm of how you see health and disease. So I've been asked today to look at what influences brain development and function, and how microbes play a role in the brain. And I'd like to go back to this fetus development. And we know that changes in maternal diet through pregnancy have a big effect on what happens later in life. And many of you are nutrition experts. In the majority of organs, the period of developmental plasticity, it goes beyond the fetal period and includes lactation. But by the third week of pregnancy, the central nervous system develops and the heart starts beating. So what have we done to the microbes in that mother that might influence this process in the first 3 weeks of life when the woman doesn't even know she's pregnant, probably? And by 14 to 16 weeks, the brain has developed to the point that the baby can suck, swallow, and make irregular movements. So brain development is critical, and we have basically done nothing. We certainly know nothing about what the microbes have done, and we've had no interventions. And what are the interventions? Pretty basic, really. It's iron, folic acid, maybe some zinc, maybe vitamin A, I don't know. But it's certainly nothing targeting the microbes. The human brain, in fact, is 60% fat. And there's essential fatty acids, and here's one, linoleic acid. Well, lactobacilli can produce linoleic acid. So should we be giving pregnant women lactobacilli, and would that influence alpha-linoleic acid in the brain of the fetus, and would that change the brain development of the fetus? And I'm going to tell you an example of lactobacilli and what it might do later on. So we live in an environment, I've told you what humans are, but what is the environment that we're in? And there's lots of toxins in this environment. And these toxins, chemicals, contribute to obesity, allergy, autism, cancer, etc. So there isn't really a lot we can do about that, but we should at least recognize what they are. So here's a study in Canada which showed that nearly 2/3 of the mother risk callers that were studied, and 23 of the Japanese women living in Toronto, and 15% of Canadian women had mercury levels high enough to cause neurological damage to the fetus. How many of us get our mercury levels checked? So if this was an MD audience, the answer would be nobody, right? Probably. But it's because you're interested in these concepts. You realize that there could be a problem. And then the question is, what do we do about it? I'll come to that later on. Our food and water is contaminated, so 70%, this is developing countries, industrial waste is dumped into the water. 40 million Americans, the drinking water contains antibiotics, anticonvulsants, mood stabilizers, and sex hormones. That was 2008. That's a lot of people. And they'll say, well, it's just trace amounts, doesn't really affect us. Well, I would suggest it might. 40% of the world's rivers and lakes are too contaminated to drink or wash in. We're not doing a good job of the planet, are we? An average 99 million pounds of fertilizers and chemicals are used every year. So here's a nice example. This is how we apply pesticides. But we don't give the kid the same protective gear when they eat it. And it's because we like to have strawberries all year. I remember as a kid in Scotland, I loved August. It was the only time you could get melons. Only time. Now I can get a melon anytime. Where are they made? Where are they grown? In other countries. And have they got the same levels? I'd suggest they probably haven't. Anyway, pesticides have been linked to many diseases, Alzheimer's, colorectal cancer, Parkinson's. And we're kind of paying lip service to it. What about other drugs? So this is pharmaceuticals in the environment. This is global occurrence and perspectives. The number of pharmaceutical detected in surface water, groundwater, and tap water. And the darker the color, the worse it is. So you know where you are right here. That's on average 101 to 200 pharmaceutical agents in our water. Now, probably Russia is just as bad, but nobody's living there, or we don't get the data. And you would expect it in India and China. You wouldn't expect in Australia or Britain. Well, this is what we're drinking. What is it we're doing? What is it doing to us? Now, you can't make those drugs. If I was to make those drugs, the company would sue me because they own the drugs. So if they own the drugs, why don't they own them until they're degraded? Wouldn't that be cool? So, all these compounds, chemicals, food, etc., they come into this gut, this amazing gut that we have, and the gut is filled with these organisms that produce different things, that dissect this material, some of it in a good way to give us things like butyrate and propionate, and some of it not such a good way, where we get p-cressyl sulfate and an increased risk of cardiovascular disease. So you're not going to change this overnight unless you do fecal transplant. You're not going to change it by popping in one probiotic unless, for example, that probiotic was specific for one of those compounds that you wanted to affect. And that's going to be the future of probiotics, where we have organisms that are doing a specific job. So, an example of how these microbes affect the gut, here's drugs. Here's other microbes that inactivate drugs. Digoxin. So if you're going to give methotrexate and it's inactivated by the microbes, then the methotrexate's not going to do the job, is it? And then there's toxicity. Some of them make them toxic. So imagine now if we go back to the pharmaceutical industry and we say, okay, you're going to have to retest all of your drugs based on the microbiota of human beings to see which ones are toxic, which ones are inactive. And you have to align your drug treatment with the microbiota of the person that you're giving it to. We would have a revolution. I'd be dead by tomorrow, shot in the streets, probably. So lots of chemicals affect the brain. There's inflammatory compounds, hormones, which is, for example, testosterone produced by bacteria in the gut. There's flame retardants, imagine. There's toluene on paint. There's lead, of course. There's methyl mercury. There's dry cleaning materials, DDT, which is still in the atmosphere, and PCBs. So lots of stuff. Chloropyrrose is a pesticide. And how are these processed? Well, here's your gut again. And here's tryptophan metabolism, toll-like receptors, cytokines. Here's the nervous system, immune system, endocrine system, and it goes to the brain. So it's no surprise then that things that happen in the gut are going to affect the brain. That's probably not going to make you fall off your seat. And if you have stress, so this is the stress profile, dysbiosis in the gut, altered gut mobility. You've heard on the leaky gut concept, inflammation. And this is all related to all these compounds, communication pathways. So these bugs are talking to your brain all the time. They have all these chemicals that talk to the brain and different parts of the brain. And that's a really cool thing. Once we try and dissect which part of the brain that they're affecting, then we'll have a better chance of having interventions. And so here's an example of the nose, right? You've got lots of bacteria in the nose, you've got lots in the mouth, you've got lots in the gut. And here they affect autonomic nervous system, etc., the brain, the spinal cord. And from Alzheimer's and Parkinson's, we know that the misfolding and aggregation and deposition of proteins in the brain is influenced. So if the microbes can influence the deposition and the aggregation of proteins, maybe that's how they're playing a role in some of those diseases. And what about viruses? Well, lots of viruses affect the brain. So measles, vesicular stomatitis virus, West Nile virus, cytomegalovirus, herpes simplex, Borna disease virus, vaccinia, chickenpox, rubella, etc. And we haven't even begun to look at the virome and what viruses are in the brain and how they're affecting things, and whether, in fact, they may have a role in some of the diseases that we're seeing today remains to be seen. But here's an interaction between two viruses associated with the risk of Alzheimer's disease. And when you have cytomegalovirus and HSV1, it's associated significantly with Alzheimer's. Does it cause it? We don't know. What do you do about it? I don't know. First thing is, if it's really involved, now that changes what we're starting to look at, isn't it? If you think this is the cause, then let's look for it and see if it's really doing it. And this is multiple sclerosis. So here's the CNS autoreactive T cells present in a healthy immune system. They're activated by bacteria and viruses. They cross the blood-brain barrier, leading to MS. So if there are people at risk of MS, then we should be looking at what viruses perhaps are in the system. And the interesting thing for me is what suddenly triggers these diseases. You know, you get people, I have a son-in-law, and literally one day he got Crohn's disease. It just, boom, just happened like that. And I think sometimes there's a trigger, and if we can understand the trigger, we'll get to solutions. Now, if you alter the gut microbiota dramatically, would it impact MS? So what's the most radical way you can affect the gut microbiota? Fecal transplant, right? So I like to ask students, would you give a kidney to your best friend to save their life? Most students will say yes. Would you give your stool? I don't know. Don't like you that much. But in fact, that's what certainly is happening in Clostridium difficile. Anyway, this guy, Tom Barodi, in Australia, did this. It's only 3 patients. 3 patients where he did fecal transplant in multiple sclerosis. And his clinic, you can basically go there, and the turnover of the clinic is incredible. But I'll show you what the conclusions were. So the fecal transplant caused a resolution in constipation, a dramatic improvement in neurological symptoms, regaining previously static motor skills, and eventually walking unassisted. 2 patients had restored urinary function. In fact, there's a paper just came out showing that fecal transplant in patients has stopped them getting recurrent urinary tract infection. Interesting, eh? And there seems to be a microbial component in MS. Now, it's only 3 patients. This was a study in Canada which showed that there's bacteria in the brain. I mean, we've always thought there's parts of our body that are devoid of bacteria. And they found bacteria in the brain by sequencing. Now, you have to be careful because some sequencing, I think we're going to be questioning a lot of 16S data because of contamination. But they looked in the brain itself, and they found a bunch of different bacteria which they claimed were in fact alive, and there was evidence that it was mostly proteobacteria and phage. So the question is, what are they doing? And they'll be in very small numbers. Why is a bacteria or a phage in the brain in very small numbers? And we did a study on breast cancer, and we found bacteria in breast tissue that was different in women with cancer than women that were healthy, in very low numbers. What is it they're doing when they have tissue, enough, all the nutrients in that tissue to grow like crazy and cause an abscess or an infection? But they don't do that. They just sit in low numbers, and we'd like to find out what that is. Because we know they produce neurochemicals. GABA, norepinephrine, serotonin, dopamine, acetylcholine. These are normal, everyday organisms. Candida is a yeast, of course. So they produce these chemicals. And people have talked about the vagus nerve, but I want to emphasize to you, the vagus nerve isn't just stuck to the gut. The vagus nerve links the eyes, the salivary gland, the lungs, the stomach, kidneys, bladder, and urogenital tract. And where are there other microbes? In all of those places. And maybe that chronic pain of chronic urinary tract infection is somehow linked to the microbes and the connection with the brain. That's an area that we've been looking at. So what's a probiotic? You don't leave the room until you can say this definition off heart. So I had 55 dental students, and I said 3 times, this is coming up in the exam. 8 got it right. So that proves it's so easy to get into dentistry. It really does. Anyway, so they got to be live. Don't call dead probiotics. They have to be administered, not consumed. It could be administered, it could be on the skin, the vagina, the mouth. Adequate amounts, you can confer a health benefit. And a health benefit is not, it changed my life. Well, you took probiotics this morning and it changed your life. That's great, but now prove that it's really because of it. And you have to do clinical trials to prove it. So let's look at some brain and behavior. So we're starting to see randomized controlled trial to test probiotics in cognitive reactivity to sad mood. We're seeing a consumption modulates brain activity, and this is imaging done by Emmer and Meyer. Lactobacilli modulates intestinal pain, inducing opioid and cannabinoid receptors, which is really kind of cool. Now, this was a neat paper, and nothing is followed up from it, which I don't understand why, but anyway. Impact of consuming a milk drink containing a probiotic on mood and cognition. A randomized double-blind placebo-controlled trial in emotional symptoms of chronic fatigue syndrome and assessment of psychotropic-like properties of probiotic in humans. And it's humans, I always really say we have to look in humans, not rats and mice. So here's a study that was done in humans, and this probiotic reduced depression scores in altered brain activity. So this is bifidobacterium, for crying out loud. Altering brain activity. And basically, if you look here, it's, the control is 22 versus 22. The bifidobacterium group, reduction in depression score of 2 points and stimuli in multiple brain areas, including amygdala, frontal limbic regions. So, I mean, that to me is just, it's kind of mind-boggling. I've just swallowed this friggin' bifidobacterium, and now you're telling me it's affecting my amygdala? Holy crap. These are important organisms, and we got to get to grips of what this means and how this is going to benefit people. And I'm not going to suggest, if you're very depressed, I'm not going to suggest this is an alternative to medical treatment. That should never be the case. But maybe it prevents people from going on high doses. Maybe it prevents people who are mildly depressed needing the pharmaceuticals. But it's something that is going to be cool to look at. And the brain effects, so this is another study in Canada. It was a randomized controlled trial, chronic fatigue syndrome, and here's Lactobacilli casei. It was given for 2 months, and there's a significant decrease in anxiety. So we are living in, obviously, an anxious society, and again, this is suggesting that we can impact that. So a nice experiment by John Bienenstock, who's a famous Canadian, and so he put these mice, I don't know if you've ever seen these types of experiments. They put these mice here, and where'd the mice go? If there was a mouse in this room, where would it go? Go around the outside, right, hide in the corner. It kind of wants to feel the edges, to feel safe. So if it goes in the middle, it's kind of chilling, baby. It's, hey, you're my buddy. I'm going to sit on your table and have some of your candies. Thanks a lot. Right, so then he's really chilling. That's the way they measure it. And when they gave these mice bifidobacterium and lactobacillus reuteri, they spent more time in the middle, significantly more time in the middle. They weren't as anxious. So again, it's, you see the animal experiments, and then you see it in humans, and it's kind of neat research. All right, question for you. Who gets a craving? Yeah, okay. I get a craving too. And gut microbes manipulate host eating behavior in a way that promotes their fitness at the expense of host fitness. So now I know. I go to buy gasoline, and I'm walking out the shop, and I'm holding a dairy milk. I just came to buy gasoline. What the hell's that? It's because my microbes have told me to buy the dairy milk. See, so it's nothing to do with you. It's your microbes, right? And people who desire chocolate have different microbial metabolites in their urine than chocolate in different people, despite eating identical diets. Isn't that cool? So if you didn't put your hand up, you're just a chocolate indifferent person. And I'm indifferent to you. All right, here's a story from 2 days ago in the Financial Times. Financial Times. Anyone seen this? Kind of neat. You have. There you go. So good bacteria can help brain function better. And this is a paper that was presented by Janet Jansen at the American Society for Science, American Academy of Sciences annual meeting. And they said this is a strong evidence associated between the brain and the microbiome, which, as I showed you, there's been other studies on this. But lactobacilli given to these mice improve memory, my favorite organism. So you must imagine how much I've been laughed at for 35 years talking about lactobacilli. I'm number one on the grant rejection panel in Canada. Seriously. And I've been talking about this organism. Imagine if it helps our memory, for crying out loud. And remember going back to the study of the fetal development? If the mother took lactobacilli, would it affect the memory of the baby? Well, that's a far-fetched, but hey, crazy things have happened, and here's one of them. And here's another thing that I love. This is sponsored by the Naval Research, because they're looking at far-ranging impact on warfighter performance. What kind of society do we live in that our research is driven by improving warfighter performance instead of, memory of cognitive impaired babies or something, Anyway, at least someone's funding it. So I told you about mercury, and there's no point just telling you what's wrong. We did a study in Tanzania. So Lake Victoria is a beautiful lake. You can't swim in it because you'll get parasites. You shouldn't really drink it. And then if you eat the fish, good luck. So it's not the big fish. People panhandle for gold in the rivers, right? And the gold is panhandled by mercury. So the mercury goes down the river. And therefore, it's not a surprise that the small fish that are in the shallow areas are caked in mercury. And it's part of their daily diet. So we went there and we did a study. We had a kitchen set up that made probiotic yogurt. We call them the yogurt mamas. And we now have about 250 of these kitchens across East Africa that are providing probiotic yogurt, the first in Africa, to over 250,000 people. Imagine. So it started like this, and we said, let's do a study of school kids and pregnant women. And the lactobacilli supplemented yogurt, just taking yogurt once a day in pregnant women resulted in a 36% loss or uptake and 75% reduced arsenic. In other words, they reduced the uptake. Now, how do they do that? Well, guess what? The lactobacilli bind to mercury and lead. So if the women are taking this contaminated fish because they can't do anything else, they have to eat the fish, why not give them an organism that binds to the mercury and then you poop it out? That's the concept. We want to repeat this in parts of Canada. You may know Windsor, Sarnia, one of the most contaminated parts of our two countries, and we'd like to do that study there as well. We then looked at these lactobacilli. Could they degrade pesticides? Actually, they can. They can degrade some pesticides, and they can degrade aflatoxins. Now, we're in America, Canada, where aflatoxin poisoning isn't huge. It's very big in other parts of the world. So if you can not only stop aflatoxins getting absorbed across the gut, you can degrade them, then you're really in a good shape. So what's the bottom line of my talk? We live in a microbial planet. There's microbes in the brain. We don't know their function. That first thing is so, so important. We've really forgotten that this is a microbial world. And if humans are so crazy one day that we just wipe each other out, guess what will be left? So who's sensible, the microbes or the humans? Rest my case. We can use microbes delivered at other sites. So gut, possibly the nose, possibly linked to the vagus nerve. You could have sprays that go into your nose that could affect these things. You can manipulate outcomes emanating from the brain, so depression, anxiety, cognitive function, pain. We've created this huge chemical implant on a planet, forgetting that at its core, this is a microbial planet. We need to better use microbes to offset the negative effects. And that might be using microbes in fields instead of pesticides. It might be microbes in different ways that we just haven't imagined yet. But that's the way our mindset should be going, because it's a planet filled with microbes. This includes crop and livestock production, wastewater treatment, air pollution, mining, and food preservation. So we're a colleague of mine's doing a study with a very large chemical company, and they have a 1 kilometer span that the chemicals go in this end and go in the St. Clair River at this end. In between, there's microbes. And these microbes are trying to degrade all the chemicals. Because if one of those chemicals, and I won't tell you what it is, gets in the St. Clair River, it's millions and millions of dollars fine for the company. So that's an example of letting microbes do their own thing. And there's other ways we could do things. We could add microbes that degrade antibiotics and pharmaceuticals into wastewater treatment plants, for example. And then pollution and mining and food preservation, this should be part of what we do. But it starts in the womb. So if we don't get brain development right there, we better make it up quickly. Imagine a planet of people with poor cognitive function. Whoops, we already have one. And they're all men. So I would like good to come from this, one microbe at a time. And if you start thinking how we can use the microbes, I think it's going to put us in a better place.